So now that we know what an eigenvalue is and kind of have an idea about the computation, let's look at a couple of just really basic questions. So my first two questions are, if I have this matrix, and you'll notice that I use the same matrix in both of my examples, can I just say, is -3 an eigenvalue of that matrix? A question like this is pretty straightforward to answer if you remember that what's true about an eigenvalue is that it must satisfy that the determinant of A minus lambda I is equal to 0. So if this is my matrix A, then I just need to calculate the determinant of A minus lambda I. So I'm going to move to my calculator here, and I'm going to put in that matrix. So this is the 2 by 2 matrix, -1, 4, 6, and 9. Take a look at it. There it is. And I want to calculate the determinant of A minus lambda I. Okay, so my calculator knows how to do this kind of stuff. So I want the determinant of A minus -3, that's plus 3, times the identity. And I can scroll down here to get that. And I have to put in that it is the 2 by 2 identity. And so this is going to calculate the determinant of A minus lambda I. And it turns out that that is 0. Okay, well, if that is 0, then in this case, the determinant of A minus -3 times I is equal to 0. So that means that the answer is yes. Similarly, same matrix, I can ask, is 2 an eigenvalue? So we'll go back to the calculator and go through this exact same computation. And I will just bring that same code up there and then move along and change this to -2. So is the determinant of A minus 2 times the identity equal to 0? And it turns out that that's 45, which is not 0. So here, the determinant of A minus 2 times I is not equal to 0, so therefore the answer is no. So pretty straightforward if I give you a matrix and say, hey, is this value an eigenvalue? Pretty easy to say yes or no. Okay, so what if I give you a similar idea, here's a different matrix, and now asked you about whether or not these things are eigenvectors. So if this is an eigenvector, it must satisfy the eigenvector eigenvalue equation, which is that A times x is equal to lambda times x. Don't really need a calculator for this one. I'm going to take the matrix 5, 2, 3, 6, and I'm going to multiply it by the vector -1, 1. And what I get is 5 times -1 plus 2 times 1, so that would be -3. And then 3 times -1 plus 6 times 1, that would be +3. And now what I want to know is this a scalar multiple of the original one? And it turns out that this is equal to 3 times -1, 1, where these two are exactly the same. So the answer is yes. This is an eigenvector, and in fact, we can also say that it's an eigenvector that is associated with the eigenvalue lambda is equal to 3. All right, how about the second part? Is 1, 3 an eigenvalue of the an eigenvector of the matrix 5, 2, 3, 6? That would be 5 times 1 plus 2 times 3. That's 5 plus 6 is 11. And then 3 times 1 plus 6 times 3, so that would be 3 plus 18 is 21. And that is not a scalar multiple, right? 3 times 7 is equal to 21, but 1 times 7 is not equal to 11. So this is not equal to some lambda times 1, 3. So in this case, the answer is definitely a no. Okay, so now what about finding this characteristic polynomial? I did one of these in the last video, and I put in a whole lot of detail there. And it turns out that there's a lot less detail that is needed. Remember that the characteristic polynomial is the determinant of a minus lambda times I. The eigenvalues are the roots of the characteristic polynomial, but the characteristic polynomial is just the determinant of a minus lambda I. So I'll just start with that determinant. And in fact, I don't even need to write a minus lambda I, because lambda I will always have lambdas down the main diagonal. So all I really need to do is subtract lambda from the entries that are on the main diagonal of the matrix A. So go to the main diagonal and subtract lambda from each one of those, and then calculate the determinant. So this would be 2 minus lambda times 1 minus lambda minus 4 times 3, which is 12. And then a little bit of algebra 1, we'll clean this up. 2 minus 3 lambda plus lambda squared minus 12 is equal to lambda squared minus 3 lambda minus 10. And this is the characteristic polynomial. Now, if I want to take this a step further and find the eigenvalues, so if the next question is to find the eigenvalues of this matrix 2, 3, 4, 1, then I want to know what are the roots of lambda squared minus 3 lambda minus 10 equal to 0. And I believe that this one also factors. That would be lambda minus 5 and lambda plus 2 equal to 0. So I would get eigenvalues of lambda equal to 5 and negative 2.